Hi, hello everyone, and welcome to this video. So basically last time we left off with our terrain, and for this time what I want to do is just create a height map and use that height map to have some kind of natural terrain here. And what is height map? Well, simply put, height map, if I can open it here, yes, we want to load it. Height map is a texture which is usually just going from black and white, and then it has all kind of shades right between those colors. And usually the white color will be height of it. We can represent with white color height of terrain, and then with lower color, right? It's just bottom of the terrain. Basically, the dark region are going to be lower, the bright region are going to go up. And we just convert it, which is just an RGB color, right? We just convert it to some height, and then scale that with some height scale factor, right? And then we can actually have lower or high terrain, and it's all going to make sense in the end. So for start, I'm just going to leave this texture in the description of the video. You can download it and add it to assets, and then I need to remember to do this as well. We just need to set copy if new or copy always, and then we're set to go. And so we're actually going to use that texture. Also, we're going to render terrain with that texture. So what I mean by that is if we just go to our terrain, and I called it height map, I believe. We can use that for terrain height map. And then what I want to do is just don't have any scaling on our terrain, because we're going to scale height map actually. So let's see what we get now. So I get this. Perfect. We have our height map. So basically, somewhere in the middle of terrain, right here where the mouse cursor is going to be like a mountain or something like that. And here where the dark regions are, it's going to be quite flat. Okay, so how are we going to actually tackle that? So one way to do it is just to load texture into memory, and we're all set. But I thought it would be interesting, like, to have ability to read texture in WebGPU. Now, for now we're using this texture, but we can try to read memory from this texture object, and that's what we're going to do. So it's kind of, this video is kind of going to showcase how to work with height map and then how to read WebGPU textures as well, which is not exactly easy, because we have to actually move our texture memory to a temporary buffer called usually staging buffer, and then we read from the buffer. So let's get started. So the first step would be actually to somehow read from the texture. And for that, we can go to our texture object, and we're just going to extend there and create some small method called getPixels. In OpenGL, if you ever worked it, it's very easy to read from texture. In WebGPU, not so much, because like I mentioned, we have to create a temporary buffer, because we cannot directly read from the texture as of yet. I'm not sure if this will be possible in future. But so let's just create a method here, and I'm just going to make this public byte. We're just going to return our texture memory as a byte array, and I'm just going to call this getPixels because it's, I think the OpenGL method is very similar named, so I think this is fine. And then we just have to start working with it. We're going to have width here. And if you remember, we had size X and then we had size Y as well. It's just that size is not immediately set, right? We just set it when we paste it here, but we want to set it from the image as well. So we can do it probably somewhere over here. We can say this size new, and then we can just take image width and image height. And that's fine. So we have defined our width and height. So let's think further. So we just need to collect information, and we're going to create WebGPU buffer here. So because the namespace might collide, I'm going to do this. Buffer is quite common name, so we're just going to use WebGPU silk.net.buffer. So I'm just going to alias it to make it clear. And then I'm going to call it staging buffer. So this is the buffer to which we will copy our texture memory. and then we read from that buffer from that buffer which is allocated on our GPU. We use it and read the memory back to the CPU. Okay, so for that, we can just have we can create buffer like this. But I think that we had also this utility, buffer util. So I'm going to make use of it, and we can just create buffer, which is going to be used for this. So I'm going to call it here public void. Sorry, not void, because we are returning here buffer. I'm going to call it create staging buffer, and I should probably make this all bigger. So let me see just the suggestion. So we have buffer descriptor, map that creation. We're going to set it to false. Why false? Because we're not mapping at creation, we're mapping later when we copy from the texture. So this is false. Size, this is good suggestion. Size is here fine. And here it says map read. That's all right, but it's not copy source, it's actually copy destination, right? Because we're copying. So let's just explain these flags. So let's go with this one. We're actually copying from the texture to this buffer, so it's a copy destination. It means we can copy to this buffer, and this map read is if you want to use to actually read from the buffer, you have to set up map read so that you can use map read function, and that kind of does some optimizations, right? And makes buffer available. So it just kind of says, okay, we can read back to the CPU from this buffer, and the rest is fine. So okay, let's go to our texture, back to our texture. So we have that. So it was WebGPU fill, right? The way we set up create staging buffer. We don't need label here, and let me just see, this is all right, I think. Right, width, height, and then there is trick though here, right? If we try to create this immediately, and let's just do this. For now, let's create empty array and see if we can create buffer like this, and I'm just going to say here 0 for some default one, and then in our terrain we can make immediately use of it. So we're going to paste texture here later because we can read from it, but just for now. So do temporary. We can just say texture get pixels. Let's see if we have any errors. So I had all of this, and it's not an issue for now, so I think this is fine. So but the issue is usually when we copy, this memory should be aligned to 256 bytes. So for now we can skip it, but later on we're going to return to it. And now we need a method, so we can say here create temporary buffer, to read from. And then we can say copy texture to the staging buffer. So now this is a bit tricky, and we can also do it in a buffer. So let's start with that method. And if I go back to our buffer util, so I'm just going to name this public, sorry, not static, void. And let me see, I have notes because I was working with this while preparing it. So I called it something like copy texture to buffer. So this will be our method, which does all of it. So the parameters that we're going to need is obviously engine, because we need device and we need WebGPU API, similar to here, right? Where we pass engine. And the second parameter is actually our texture. And here it suggests .net, so that's wrong. So let's just do this WebGPU texture just because of the namespaces. So this is going to be our source texture. So it's our source. We copy from the texture. Then we have our buffer, which is our destination buffer, to buffer which we will copy to. And then we're going to need a bunch of parameters. So here, I'm just going to say padded bytes per. And then we have rows per image as a parameter. Is that right? No, I don't need this actually. We're just going to use uint width and uint height. So this is our texture width. So maybe I should just be more precise. Texture height and then texture. So let's go further. So now here is the tricky part, because this scoping is not that simple. Maybe. So yes, this is what I wanted to showcase. If you remember, at one point we talked about the queue, and that all GPU operations need to be submitted to this queue. For example, rendering, right? And then compute shaders. And I also mentioned briefly some blit operations, right? And the blit operations are operations when you copy from one source to some destination. So here the common would be copying from texture to the buffer. So we're actually going to have to submit this to queue. It's not just easy as saying some texture get pixels. All right. So what we're going to need to do is copy our buffer to our texture, and we need to submit that operation to queue. So let's do that right now. And that is going to be something like this. We need a command encoder. So I'm just going to call it bit encoder, and then we can create it. So we have our engine, WebGPU, let's create a command encoder. That's fine. Then we have image copy texture, and I'm going to call this source because it is source, right? We're copying texture, and then we just need to assign that source texture. MIP level is 0, and then the origin is 0 as well, not super important. And then we have image copy buffer, because we're copying to a buffer, and I'm calling this destination. That's fine. Destination, what's our destination, right? So destination of buffer, right? We assign our buffer. Then we need layout, and here is tricky part, right? It asks for bytes per row, but if we just try with texture width times 4, which is right number of bytes, then it's going to end in error probably. So we can test it out. So then our next parameter is going to be in here, image extend. It's actually just called extend 3D, I think. Yes, and that's copy size, that's our width, height, and then we don't have any layers. Here it's complaining about this. Why? Because we call it texture width and texture height. And here is the method that we actually need. So we need command encoder copy texture to buffer. And we just need to pass that encoder. We need to pass source, right, destination, and copy size. And that's it. And then we need to execute those commands. Execute commands. So how do we do that? We're going to have command buffer, right? With command buffer. For this encoder, we have to say finish with it, right? With our blit encoder. And then we just need to submit it to our queue. So basically, what we did here, where is my drawing app? So what we did is basically created our, where are you, command encoder, right? We said we put this command, which is copy texture to buffer to it, right? This is our some command, and then we have queue, right? If you remember, we can put anything to queue, and we just then submitted it to queue. That's it, exactly. And then finally what we need to do is just, well, this is it. We just need to release our resources, right? We're basically done. Everything is submitted. So we can just release our command encoder, and then we can release also as well print encoder. Sorry, we can release our buffer and then the encoder as well. So this is it. And if we go back to our texture and call this, let's just see if it's going to end up in error. So we call it, it's not on texture, it's actually on buffer, but it could be on texture as well, right? Copy texture to buffer, engine. So here it's reversed. It's our source, staging buffer. Then we have padded bytes per row. I'm just going to say weak here as well. For now, we're going to fix that later on, but if we try to copy, let's see if I ended up with errors. No errors, which is, here is one error. So the problem here, it complains about texture missing copy source usage flag. What does it mean? Well, as we need to mark our resources and how are we going to use it. If you remember, our texture has usage binding, which means it can be used in shader, and it has usage copy destination, right? Which means we can copy to a texture, but it's missing copy source, which means we cannot copy actually from it. So we just need to fix that as well. That's not going to be that hard. So if we check here, we create, and this is, we need this image overload. So if we checked here, right, we had texture user, texture binding, and copy destination. So we just need copy source, but I don't want to do that for every texture because of the optimization reasons, right? So we can just say here texture usage, or texture usage, and by default we can leave it as this, and then we can paste additional usages here. So we can just say this. Then we need to do similar for this overload. So I'm just going to copy this and where the image is, right over here, and then I'm just going to paste it here. And finally, if I do it in a texture 2D, so we can just say here texture usage. Usage is this, and also texture usage copy source, which means it can be copied from, in our case, the buffer. So this is not most optimized because we're still doing it for each of the texture that has image. Maybe we can just do it like this. We can say private read only, and then we can say bool, and then we're going to say, we're going to create some small boolean, can be read from, should, now the variable name can be read from. You can actually think of better name, but I'm just going to paste it in here and say that false, right? And then we can do this. And if that's the case, right, if can be read from, we can actually paste this copy source usage to it, and then it can be read from. So here, let's see if we will still get this error. Let's see, I have an error. Here it's complaining because I pasted to cube, create cube texture. I don't want to actually do that. So copy destination or texture usage, texture binding. That's my mistake. I actually wanted to do it in here, right? All right. And I left some descriptions here, but let's try it again. All right, let's see. Does it complain somewhere? It's still copy source. Of course, it complains about it because I forgot to paste it in our terrain when we create a texture. So we can just say here can be read from. Yes, true. We actually want to read from it. So now we should not have this error. It was somewhere at the top. And now it's complaining about what I mentioned, copy bytes per row alignment. We need to align those bytes. So now that's the next step. And if we check here, this is WebGPU documentation which we're using, right? We're using the WebGPU from Mozilla. It says here, buffer texture copies must have bytes per row alignment to this number, which is 256, right? So we actually need to respect this. So we're going to do that, and this is exactly what I mentioned that we're going to need to do. So back to our texture, if we go to texture 2D, so we need for this parameter, right, padded bytes per row, we need to align it. So we can actually say here you padded bytes per row is equal to, now this is a bit tricky if I remember correctly. So what we need to do is take a width times 4, right, because it's bytes, and then to it we add 255, and then we do this exactly. And I just need to cast it everything to uint. So quite a bit of hassle here, a lot of brackets, but hopefully you get the idea. So now just to explain this a bit. So let's try to somehow explain this, and I did the math here. So what we basically have, can I zoom in? Perfect. So what we did is, right, if we try to take our image width and then multiply by 4 and divide that by 256, right, we get decimal number. So that's no good, that's not aligned. But what this does is if we add here plus 255, and then we need to do this as well. So and let's just, I need to add brackets here. We get 17. Obviously that's not good. So I just wait to close this here. Then we have this and this. Still not good. Yeah, that's good. So it's aligned now. And what does this do? This 255. So we can also take a look at, and that is, we can do it like this. So I'm just going to put brackets here as well. That's 4, and we can do 2 string and then place 2, right? And we get decimal representation of it, right? So what we had previously, when you do this 256, if you check this number, so it's not 256, it's 200, no, that's fine, that's fine. So if you check this number, we can see this, but it's a bit confusing. I always hate working with these bytes operations, but well, let's try to do it. And then what did we have? And not 55, right? Basically, we're saying just this last 8 bits, right? It's not one of these, so it kind of sets them to 0 and aligns them properly. So hopefully you understood this. I suggest maybe reading on it a bit because, to be honest, I'm not best at explaining this. But basically it just aligns it properly, and that's what we did here. So we can now use it. So it means it's aligned to 256. And then if we try to do it now, if I press here padded bytes per row, I think it should not complain anymore. Basically, no, not this. We need this, and then if I check it, it still complains. Copy bytes per row alignment. Did I paste everything correctly here? Probably not. So here it's padded bytes per row. So I'm just going to place this right over here, and then let's try once more. And if we read everything correctly, Okay, so now we get different error, so it means somewhere our size is not probably properly set, so let's check this. Okay, I think it's actually very simple because our buffer does not have enough size, so we're just going to move this over here even better, and then we don't have to multiply by 4 here, right, because petabytes per hour are already multiplied. So if we do this I think it's fine. And here, copy texture to buffer, we have to have petabytes per row here. I think this should be fine. So yeah, okay, it's good now. So my suggestion is when you're working stuff like this, just have validation enabled and then always check what you're doing. But we're good here. So essentially, what we did is we successfully copied our texture to a buffer. Now we need to read from that buffer. So for that step, we're going to create another utility method, and that's going to be in our buffer util. So I'm just going to call this public void read, and it should return bytes, but we're not going to return bytes immediately because we're going to pass callback due to this operation of map read being async. So just so that you're aware, so we're going to have here unit byte size of bytes that we want to read, but here we're going to have action, and we're passing callback usually in C# if you work with something that's asynchronous, you work with async await. But as you remember, this WebGPU are very low level bindings to basically Rust or C++, I don't know anymore. And here we actually have to pass callback. So we're just going to have here action, and we can delete all of this because we're going to have something, and we're going to need this boolean is read. So you're going to see what is it used for later. But then we have this action WebGPU, which is called buffer map async. And here this is important, right? If you remember, somewhere in our buffer, when we created this staging buffer, we said map read. So without this, this method cannot be called. So just so that you're aware why it was called read. And then we're going to say here our buffer, which we're reading from. The next is map mode, and here we are actually reading from it. Then what's the next parameter? I think it's offset, which is just 0, byte size, the amount of data that we're reading. And then we have to create this callback. So let's just create callback here. Buffer callback. It's going to be just called callback, and then we can create it like this, and then we can say from. And here it has 2 parameters. So one of which is, I just want brackets please, status, and the second one which is just some pointer of message, and that's all right. We're going to work this callback later, but for now we just want to pass it in. And then we have user data, which we don't care about. So you can actually specify user data here and then read it here as a third parameter, I guess. Right, user data. I guess you should be able somehow to read it as a third parameter, but for now we don't care. We just need our status, and this message pointer is just a message that WebGPU is going to give us. And that's fine, but here, this is the trick, right? And this is asynchronous, and we don't know when this is going to be executed. So what we want to do is, while it's not read, and there's all operations, we actually need to submit this to queue, and we can just keep submitting, right, until it is read. So we can say here queue submit, and then we pass engine queue, and that's it, right? And then if read, right, we can just say is read. So what we're going to do is we're just going to keep submitting until this is actually properly read, and then we can just say is read is true, and then we're done. So this might not be the fastest way, but here I think it's fine because we're going to do it while we're essentially loading, and then we just need to unmap the buffer, then we can destroy it later on. This is not too important, but what we actually need to do is check this status. Actually, you don't have to do it, but it's probably a good idea. And if it's not success, what I just want to do is we can cast this message and then get message. So, and this is just saying if something went wrong. If you remember correctly, we use something like this, pointer to string, and then we just need to cast this integer pointer. Say it's always available. We can just do console write and then enter. And here is important part, right? So here we can actually now call. So we're going to need this engine, WebGPU, buffer, get mapped range, and then we can get the data. And here is actually data, and then we actually make use of this section. So because this might be very confusing, let's just recap. We actually call buffer map async. So this kind of says, okay, you are available to read from buffer, but we don't know when this is actually going to be allowed because it's async operation, right? And then we just decided, okay, let's just keep submitting the queue until it's actually this is called, right? And after this is called, we're just going to continue. And here, once this is called, our buffer is ready to be read from, right? Then we just read from it and then execute this callback and get this data back. Okay. Like I mentioned, it's not actually that straightforward to read data from the texture, but we are going to survive this. And it's actually kind of good to know how to do it if you need to do it ever. So it's not a bad idea to have that code lying around somewhere. You can always go back to it. And finally, we did all of that. If we go back to our texture 2D, we can make use of it. So the amount of data that we need to read is our bytes per row, which is just width times, sorry. So we're actually reading our padded bytes per row times height, but our texture data, right? So we can finally create these bytes that we're going to return. They can actually be smaller, right? We don't need padding here technically, so you can leave it, but I don't want to have it. So this is width times height, and just multiply by 4, right? Because our width is not bytes per row, right? So we need to multiply by 4, and then we can use that WebGPU till buffer.read. So we're going to need engine, staging buffer, then byte size. We're reading our padded buffer, and then we have this callback. So it's just a pointer. Then we can execute it. So here we can actually cast it. Data pointer. Let's just cast it to bytes. So now what we want to do is just go through all of our rows, which we can say is a height. Let's remove this. This is not good. Usually these AI packages which I use Copilot, they're not really good at this stuff. So what we need to do here is find our row, which is just width times 4, right? Because we have bytes, and then times y. So this will give us our row, but we need also padded row, which is our padded bytes per row times y. And we just probably need to cast it because I said integer here. So, right, padded bytes per row already contains this 4, so we don't need to multiply it again. And then finally we can copy all of this. So we're just going to go through our X, which is it, and then X plus plus. So here we're going to need destination index, which is our row, plus X times 4, and our source index. So basically our destination index is going to be index of this data, and our source index is going to be from this data pointer, right? Our source is our buffer memory, and we just copy it to some CPU memory. And this memory is also on the CPU. We just want to get rid of this padding, right? We don't need that. So this is why we're doing all of this. So we can just say destination index, and then we just need to copy all of this. So we can say here red, right? Green, blue, alpha, and we're done. So finally, we can return this data, but what I just want to do is release this staging buffer, right? So this is temporary buffer to read from. We can release it. And then finally we have our data. And if everything is all right, we should have some data here. Let's just try it out. So let's see, do we have anything? Yeah, we have our data, and usually, right, you're going to have here red, green, blue, and then 255 for alpha, right? So every fourth entry is going to be 255 because that's alpha value. So all of this is very good. Finally, we need to add it to height map somehow. And now the tricky part of adding this to height map, which actually it's not super hard, but we're going to go to our geometry builder, and what I want to do here is following. Let me see how I imagine this to be. Okay, so here, create terrain geometry. We're actually going to pass texture 2D here. Height map texture. So I'm just going to break this into second row. So this is our create terrain geometry. So what I want to do is get those bytes. Height map bytes. And we can call that method get pixels, right? So further, what we're going to need to do is somehow convert this so that we can use it as a float right over here. Right, we use the random for our height, but now we're actually going to read those bytes. So we're just going to need some small conversion method to convert bytes to float array. So we can make it as a list of list, and what's going to be why it's 2 times list? Well, because it's going to be width and height in it, or as we called it here, actually I think our length and width, and length is just height in this case. Height map bytes to floats, very simple name. So we need that byte array bytes, then we need integer width, and then we need integer height, and that's from our height map. Then finally we need this height result, and then we're just going to keep adding to it. So you could use array probably here as well, but I'm just going to be lazy. It will probably be faster with array, but whatever. So we're just going through that height once again. So let's check here. Row. This is actually not a bad suggestion. We could use it like this, but what I want to do is actually make it a bit simpler. Add new list of float. Right, we're going to fill in our rows now, and then we go to our width, and here it's all wrong. So what we want to do is get red color, which is our bytes, and this is good suggestion, right? It's our row plus whatever the x is, and then we just need to multiply by 4, and we can say here plus 0, and this is our red. and we divide by 255. Why? Because it's in bytes, right? If you remember, bytes go from 0 to 255. If we divide, we're going to normalize it, right? If it's full color, right? If it's full red component, it's going to be 255. If we divide by 255, it's going to be 1. So it's normalized to 1. So we need to do for all of this. Alpha is not even important, so we can actually heck. Yeah, we don't need alpha actually. So this is going to be our result. The row that where we're currently in is our y, and then we can say add, and here we just actually need RGB, and then we divide it by 3.0f, and here I'm just going to subtract 0.5f. Why? Because our space, I want to go from minus 0.5f to 0.5f, right? So with all of this, it's going to be normalized in 0 to 1 space, right? If we add all of this together, and let's say that RG and B here are 1, divide by 3, we get 1. But I actually want to for it to be 0.5, right? Because I just want to have a terrain centered in the middle. Okay. We're almost there. We just need to return that result. Almost there. So here it's list of floats, and that's called height map now. All right, we're almost there. Do I need any other information? I don't think so. So here, now it's also a bit tricky because this height map doesn't correspond to this width and length. So we're going to have to account for that as well. So here we already normalize this texture coordinate, so we can actually say here float x normal, and it's going to be equal to this. So, and then we're going to have z normal as well, float z normal. And so I'm going to explain this in a second. Height map x is going to be integer, and here it's a good suggestion almost. So what we are doing here, height map texture dot width. Does our texture has width? No, it doesn't, and this is wrong as well. I just realized, because this needs to be from the height map, not this width, right? If you remember, when we're creating terrain geometry, we said, okay, we want our terrain to be 64 by 64. But our texture is, in this case, I believe it was, doesn't show here, but it was something like 1025. So what we're going to need to do still is go back to our texture, and we actually need to expose this size. I'm just going to create here public integer width, which is going to be size x, and then similar for height. So let's just get back to our geometry builder. So this needs to be height map texture dot width, and then height map texture dot height, and of course I hate this casting stuff, but okay, that's my bad. So we need this, and then we can actually read from it. So this is almost fine, I think. And what we need to do is use our height map, and then just put in those values. First of its length, and then its width. So, and if I try to run it now, nothing happens, because so we can get rid of this, and we can just pass texture here, because it's also our height map. Okay, it's complaining why height map x is 2025. This is 0. Aha, because texture width is 2025, but it means our number of elements is 1 less than this. So what we can do is just go here. move this to and do this -1 -1. And if I try to read now, it's actually fine, it's working. So I'm going to get back to this and then try to explain it. I just want to check if everything is sort of alright. It doesn't have to be like fully alright. We're going to have to do small changes here probably, but let's say 11 is value I used for preparing for this. And we're there. Excellent. This is totally fine. Oh wow. Yeah. So just to explain this a bit, and then we're going to do a recap and explain everything. So where was I? In our geometry builder. Here I wanted to explain this part. So here problem is, right, our terrain width is 64 and 64, right? But our texture is actually 1025. So not all pixels matter. What we did is we kind of just normalized it. Let's say that here, right, this x normal. So if we have some number, let's say 16 divided by 64, we would get something like 0.25, right? We have 0.25. What we did then is, okay, let's take that 0.25, right? And multiplied by 1025, and that's roughly some good corresponding pixel from our height map, and we would get, well, what will we get here? Something like 2025 6, I assume, something like that, somewhere over here. And then we have some good value here for our height map, right? And then we can read it properly. So that's it. It's just a bit of mapping from one space to another. But as you can see here, this works quite perfect. I don't see any issues. Our boxes are rolling. They're hitting the height maps. They're rolling. They have large velocity, so they're rolling quite a bit. But we're done here essentially. So yeah, this is how you can do it. Hopefully you understood everything. Actually, the whole height map part is not hard. What's hard was getting those pixels, but I wanted to do it this way because then you know how to read actually from the texture in WebGPU, and this is useful in a lot of cases because for the example here, you can actually create a texture and then read from it, right? Instead of having a chunk of memory from just reading the raw data. But this is also useful, for example, if you're doing off-screen rendering and let's say that you want just to save your texture to PNG, right? Or even on-screen rendering, you can save here to PNG, no problem. That's about it. So just to recap what we did. So starting here, let's start with this code. So basically we just read pixels from our texture, right? And then map it to a float. We need those RGB values. We mapped it to a float array. What we did here is just modified space a bit so that it's printed properly. And then we already had all of this set up. We just needed to read those floats. And then we had our height scale factor. If you change this to some wild factor, right, your terrain is going to be quite a bit bigger. So here we've just add one more. So let's see what we're going to get here. It's probably going to look awful, and it is awful. It's just on second screen. It looks very bad, but yeah, it's just playing with values, so you can do whatever you want. Then finally that get pixel method, which is not easy at all, but hopefully you understand it. What we need kind of to do is create a temporary buffer to which we can copy, right? So that's why we paste this. If we check here, copy destination and map read. So because we need to read from it as well, it's just our staging buffer or temporary buffer to which we can copy the texture. We do that copy texture, and here we just had we had to like submit this to a queue via these command buffers, and we did that, exactly that, right? Submitted to a queue our command buffer. We just have to be mindful that our buffer needs to be padded when we're copying to it. And then finally, we could use this read operation, right, for reading from the buffer to actually read the data in. So to actually get the buffer mapped range or the pixels from that buffer, we actually needed to call buffer map async. When it's ready, we can read from it. Yeah, once we read, this is just filling out data. This is not super important. We were just copying from pointer to our data array. And yeah, that's it. So hopefully you enjoyed this video. It was kind of hard, but finally we're there. So for the next time, we just want to use this, and we're actually going to do texturing here. So we just want to have a grass, maybe dirt, something like that. So that's it for this time. If you like this video, maybe like, subscribe, leave a comment if you want, and until next time.